All right, we're going to be working on Chapter 4 exercises, and I'm poised right now in my Spider IDE to begin working on exercise 4.2a. So I've gone ahead and created a new program file here. And the description of what we need to do is this. Write a program that reads a sequence of integer inputs and print whatever it indicates here. So the sequence of reading in the integers is something that we're going to use for all of these programs. So one of the pieces that we're going to build right off the bat is going to be reused. So that's kind of the nice part of it. So let's do this. Let's figure out a way how to get a sequence of integer inputs. And this is the real basic approach here. I'm just going to copy and paste it onto the screen. And you can see I just have a little input statement here. It says enter an integer blank line to quit. So the moment they enter nothing, they're done. All right? We're going to take that input and we're going to store it in a variable called input str, which indicates that we're storing it as a string to start. So in other words, we're going to do the numeric conversion after the fact. We're not doing it right up front. There's a reason for this, and that was explained in the chapter. Because if they enter nothing, that still comes in as a string, and I can read that empty string and terminate the program based on it. If it's not an empty string, then I will convert it and use it to do the work. All right, so that's kind of the thinking. If you want to throw comments in, if that's helpful for you, the comment I would put above the first line would be something like this. Read the first input value from the user. All right. All right, now let's go on to the next part of the logic. Let's just say that the user is putting in the right thing. All right, so let's put in this stipulation. If the first value was an integer, process it and the remaining input. Otherwise, an appropriate error message is displayed. So how do we check that? Well, we're gonna use an if statement to check it. So we're gonna start with an if, and we're gonna check that input str, that variable that we created, and we're gonna say as long as it is not equal. So we do exclamation equal, not equal, to a blank string. And we put in our colon. Then we're gonna do some stuff. Okay? What's the first thing we would do if they enter a number? How about this? How about we set up a variable to hold the value of the number after we convert it to a number? So we're going to take that input string variable, put it inside the int function, and then store that value inside a value. All right. That's a good first step. But what's the goal of our program here? The goal is to print the smallest and largest values entered by the user. That's the goal of the whole program. And just in case you forgot, here it is as a comment right here at the top. Those are the instructions. All right, so how about we set up a couple of variables then? How about we set up one variable that will hold the smallest value, and we don't know what it is yet, so we're just going to preset it to value, and one that's going to hold the largest, also we're going to set that to value, just to start with. Okay, that's the if statement. The next thing that we want to do is the user's going to once again be given the opportunity to input a value again. But what happens if the user decides not to enter a value? What should happen? And give them a message saying, hey, all right, you're all done, right? So why don't we put that in right away? So I'm just putting in a message that says, no input values were provided. So there's kind of like the whole crux of our if statement. So if they enter a number, we convert it to a number, and then we set it to smallest and largest, at least to start with. All right. Now, how are we going to check to see if something's bigger than something else? Now, that's a separate issue, right? And then how are we going to prompt them in the aftermath to figure out if they're putting in more numbers? Well, here's how we're going to proceed. The logical place to do this, and you might struggle with this part of it, okay? And the reason you'll struggle with this part of it is because you're not thinking in this capacity yet as a programmer. My hope is that over time, especially when you get to like learning a few different languages, right, and you see that there's certain patterns that repeat, you'll latch onto this a little bit more quickly. I think what a lot of people would do initially for this problem is they would write a while loop, probably, to solve it. And you know what? It is solvable by using a while loop to do the logic. But I'm going to show you a little bit different approach that hopefully will help you. So where I'm going to put my next bit of logic and the while loop, and you got to watch this, I'm going to put it actually inside the if statement. So I'm going to start by saying this. All right. As long as the user hasn't entered a blank line, convert the input to an integer and determine if it is a new smallest or largest value. Now, I know that I preemptively set those values up here in the if statement, right? Because the first thing they enter, guess what? It is going to be both the largest and the smallest right off the bat, right? So you may as well preset it. That's the thinking. Now, in order to get a while loop to function, to test additionally, I'm going to type while, and what are we going to check? We're going to check that same input string that has not been converted. It's still a string, and we're going to use the same exact logic we did for the if statement, checking once again for it to be empty. All right, so your thinking should be this. If it starts out empty, it'll never hit this, right? Right. If they type in a number, it will get to this, so the while loop will execute. If it makes it past that first if, it also makes it into the while loop. So the input string not being empty is our sentinel value. As soon as it is empty, boom, we're out, because we're using reverse logic here. All right? Once again, we're going to make that same conversion. We're going to take this line and make it the first statement inside the loop. Now that we're inside the loop, now we start checking and comparing. Okay? Here's the thinking. At some point, we have to prompt the user to put in more information. And that's got to be somewhere in the while loop here. So I'm actually going to put it like down here at the bottom. But before I prompt them, I need to take whatever value they've typed in most recently and compare it to the values we already have to see what is the largest and what is the smallest. So one of the trickier parts of this assignment is figuring out that logic. So here's the logic, folks. If your value is smaller than smallest, then smallest will take on the new value of value. I don't need an else here, because if it's not, it's just not. There's no else. All right. If the value is greater than the largest, then largest becomes whatever your current value is. Just like so. Now, if it helps you to separate this stuff out, like some people will write the code like this. They'll leave a space after that, and a space after, they might even put a space in between these. That, I'm going to leave that on you. To me, the way that I have it laid out here looks pretty clean to me, and I can read it just fine. The indenting helps a lot. All right? So here's how this loop is going to operate. I type in a number, it clears the first if. It presets largest and smallest. That same thing happens again when you go into the while loop. The while loop executes because it's a number, and once again we convert it to a number. But now we start checking. Initially, value is going to be the same as smallest, so we don't need to, so the first condition's not going to hit, the second condition's not going to hit. Then it goes right to the input statement again and says enter the same thing. Enter an integer or a blank line to quit. So if they enter another number, now it goes back up to the top of the while loop, says is it empty? Nope. Convert it to a number. Is that value smaller than smallest? If it is, now that's the new smallest value. If it is not, no big deal. If it's bigger than the biggest value we have so far, then that becomes the biggest value. Ask for another number. So there's no predetermined amount of times we're asking for the number. The user controls the loop by virtue of what they enter at the keyboard. The moment they enter nothing, it pops out. And then we go to the else, and it gives us an error. But wait, we still need to display, once this loop is done, what's the biggest and what's the smallest, right? Right, okay. So that's the one piece we're missing here to finish off the program. Where we're going to place that is after the while loop. Now I want you to notice, I put my cursor here at the end of line 29 and pressed enter, and where did it put me? In line with all the statements inside the while loop. Guess what? Python reads that then as being part of the while loop, which is what we do not want. So I'm going to hit a backspace to take us to this level right there. And then I'm going to type my print statement like so. So after the while loop is done, how does it end? By the user entering nothing. Then we're going to output the smallest value is and the largest value is. All right, so here is the completed program in its entirety. It's all up on screen. Let's go ahead and give it a run and see if it actually works. All right, saving the work, hitting the button. Oh, I got an error here. All right, what's my error? Let's see if we can. All right, file, exec file, fread, namespace, line 23, while input string does not, okay, unit indent does not match any outer indentation level. It's saying my indentation is messed up. All right, so here's what I'm going to do. I'm going to press enter. It seems right to me. And then I have my ifs, and those are indented. That seems right to me too. So is it correct for our while loop to be inside the if statement? That's kind of what we're coming down to. Any thoughts, folks? I do. I absolutely do. So if but you notice, you see where my cursor is when I press enter there?
Looks like you're off by a character.
Yeah. Good catch. So it looks like I'm off by one character. So if I do this, yeah. Let's see if that helps. Let's try it again. Notice how the little thing went away, right? And now it's flagging the same thing down here. And I'm catching this before I'm even running it. So just that one level of indent is enough to throw it off. So if I have any one complaint about this language, it's that. that it's an indent-based language as opposed to one that requires semicolons and curly brackets? All right, let's try it now. All right. Enter an integer or a blank line to quit. So I'm going to type in 1, 2, 5, 9, nothing. Is it right? It is. All right. I might say that in order to make it look prettier, I might put an escape sequence in here for a new line. Let's try running it one more time. I'm going to hit nothing to start with. That worked too. And see, you should test all the scenarios. One more time. See what I try to do to it? I gave it two of the same smallest values, and it still got the right one. You guys all good? Let's move on to the next one. Next one says the number of even and odd inputs. So we have to figure that one out. So let's do even odd. All right. Here's the beauty of this. Some of this can stay the same. You guys with me? So I'm going to actually copy all the code and then create a new program. So we're going to call this one 42B. Saving it. I'm going to paste everything in. You know, at this point, I'm going to get rid of all the comments that I have. I kind of figure I don't need them at this point. I think you guys are kind of in tune to that at this point. And let's figure out what can we keep here and what do we have to get rid of. Well, I think this input that we start with is fine. Would you guys agree? Sure. Sounds good. All right. The other thing that we're going to do is we're going to actually, per the program description, the number of even and odd inputs. You know what? I better set up some variables to keep track of the number of evens and odds that we have. In fact, I might do that right up at the top. I might preset some variables. So I might say even equals 0, odd equals 0. Just to store our count. All right. I think this line is fine. Now, do I need to have an if statement to preset largest and smallest? No, I don't think so. I don't think we need that at all. Let's get rid of that. Does that mean, do I still need a loop? Well, if I'm going to keep asking the user for input, yeah, I'm going to need a loop just for that. So you know what? Let's pull the while statement over and let's reduce the indent. And then I'm going to line up all my stuff here. Now, I'm not saying that all this stuff is keeper. I know the first part going to have to be there. Why? Because I have to still convert it to a number, right? What I have to do in this spot is figure out if it's even or odd. How do I figure out if something's even? How about if I mod it by 2 and the remainder is 0? That's how you figure out if it's even. So if I mod by 2 and that equals 0, there's no remainder, then even equals even plus 1. Else, what is it going to be? If it's not even, then it has to be odd. There's no math I even need to do on that one, right? Because all they can enter is integers. So if they're either even or they're odd. That's all there is to it. All right? Now, do I need to do the prompt them for more input? Yes. So right here, I'm going to prompt them again. This is inside the loop. What should my output message say? Which is not going to be in the loop. How about something like this? The user entered whatever even values and whatever odd values. Do I need this else at the bottom? Well, no, that went with the original if, right? So if in this program, if somebody just types in nothing, what happens? Nothing. It just exits. You know? So, I mean, if you want to put in a value, you know, want to say a message, you could just say, and I would put it up here. You know, I would say, and this is just a what if, folks, okay? You could say if input str equals what? Equal blank, then what would I do? I mean, we could give them a message and saying, program done, you entered nothing. I'm just, you know, putting it out there, right? And if they entered nothing, would the while loop ever execute? It won't, right? But we'll still get the message at the bottom that says the user entered, and what will those read? 0 and 0, right? All right, let's give it a shot. All right, enter an integer or a blank line to quit. So I'm going to type in 1, 2, 3, 4, 5, 6, and enter. Did I put in 3 even values and 3 odd values? Yes, I did. Let's run it one more time. Let me just press enter. I'm going to argue that we really don't need that if statement that I put in on line 11 and 12, that if we got rid of that, it would just say user entered 0 and 0, right? All right. This program's done, folks. You don't need to make any more out of it. Ready for the next one? All right, the next problem that we're going to work on says, so we want cumulative totals. For example, if the input is 1729, the program should print 1, 8, 10, and 19. So every time you add a number, it adds to the total and shows you what that total is. Like a cash register. All right, pretty simple. All right, so really what we're building is something called an accumulator, by the way, if you're curious. All right, let's go ahead and create another new program. Save as. You guys know the routine now. Exercise 4.2 part C .py. All right, so for this one, are we going to have to prompt the user to do the input again? Yes. Can we use the same stuff we've used? Absolutely. So that's what I'm doing. I'm just putting in an input string, enter an integer blank line to quit. Same logic. Could we set up a variable to keep track of the total. Absolutely. In fact, kind of required. Could we also use that same loop approach that we have all along for all of these? Absolutely. So we'll check to see if it's blank. If it's not, we convert it into a number. And then at the bottom of that loop somewhere, should we ask them once again to enter the information again? Yes, we should do that too. So now all we need is, what does it take inside here to get the job done? Well, every time they enter a number, we're going to do what with it?
Add it to previous numbers.
Yeah, we're going to add it to whatever our total is, plus whatever the value is. That's the number that was just typed in. The other thing we'll want to do is we'll also want to give a message saying the cumulative total is, and then, gotta put that comma on the outside, that's right, is total. Do I need to do anything else? Well, okay, I could argue that if you put in a blank line, you could copy that if statement we had in the last program, right? But if they don't enter anything and they press enter, what's the total anyhow? 0. So it doesn't really make a difference. I'm going to say no. All right, running it. Oops. All right, blank line. Oh, wait a second. It didn't do anything. But you know what? Entering a blank line, it does say blank line to quit, so you just quit right away. All right, let's do that again. Let's run it again. Now let's put in some numbers. 1, 2. Is the total that's being output correct? 3, 4, 5. Yeah, it looks like it's working great. Nothing, we're out. What is their sentinel value in this while loop?
0 string.
Yeah, that would trigger it to false, yes. But it's the input string is the variable that's technically the sentinel value, and the value of blank sets it to false, which triggers it out. Okay. Moving on to the next one. See, these are actually pretty simple, folks. It's just like reading it takes more time than doing the code. Okay, all adjacent duplicates. For example, if the input is 1, 3, 3, 4, 5, 5, 6, 6, 6, 2, the program should print 3, 5, and 6. So they're looking for anything that's entered more than twice in a row. All right, that sounds a little more complicated, but I assure you it's really not that bad. All right. Can we start with the same code again? Yes, we can. All right, new file, save as, exercise 4_2, part D, .py. All right, let's get that input in there one more time. So we know this is going to be there. All of them have it. All right. This is going to take a little bit more thinking. If I want to check a value that I've typed against the value that was already typed, we will need to have some sort of a variable that holds that value in order to check it. All right, so here's what I propose. Let's create a variable called previous, or prev, and it's going to just take that input string and store it. Once again, we're going to run that while loop. Right, and as long as they type something in, we're going to keep going. So what would be the first thing I'd want to do inside the while loop? Well, I've already grabbed one input and stored it. Now I need to see if the next one matches it. So I need the next one. So I need to do this next. So I need to ask him for another value right away. Now here's where our logic is going to come in next. All right. This might take a little bit of thinking because, all right, so if I'm checking to see if the values matched, really all I have to do is check if the input string we just got, the new one, is equivalent to whatever we put into prev or previous. Then we should print, let's print what those are, right? You could say input str, and we can leave it as a string, it doesn't even have to be a number, is a duplicate. All right. Are there any other scenarios we have to worry about? Well, I'm going to be typing more than one number. Here's one, that's one catch, right? So whatever I just typed now gets stored in previous, like it did above. So that's got to be part of every loop. My question to you is this enough here to make it all work? I'll tell you what, only one way to find out. Let's run it, because it can't be this simple, can it? There's a typo on 17. Oh, thank you, sir. See, that's what I have my students for. All right, let's run that again. Well, I guess I'm going to enter a blank line to quit, and let's run it again. All right, so I'm going to type in 1, 2, 2. 2 is a duplicate. That's good, right? 3, 4, 4, 4, 5, 3, 2, 2, 1, blank. Am I okay? All right, here's the catch though. All right, if the input is 1, 3, the program should print 3, 5, 6. Did it print all the stuff that was duplicated?
Not in that format.
Not in that format. So you guys see a problem with this?
Yeah, we have to take all the numbers first.
I'm not sure we necessarily have to do that.
No?
I'm going to show you what the author did, and I'm not really sure that I agree. But this is what he did. He also added some variables. A variable, actually. He added this. He added a variable to check to see if something's already been printed. But then I see a flaw in his logic, which is why I didn't include it. He also added this to the first if statement. So if you keep entering a value, it's not going to keep reprinting it. That's the point. Right? I see a logic flaw in his code, but he also added this, which I think is interesting. This is what the author did. Do you see how my solution got to the same, it worked. It didn't print it in that format, but guess what? The author's isn't going to print it in that format either. Is it? So, what you saw first was my solution. Here's the author's solution. Should we try his? Sure, why not? Okay, 1, 2, 2, 2. See the difference? Mine would have printed 2 as a duplicate again. His is not. 3, 4, 4, 4, 5, 5, and exit. Is there a way we could store those values and then output all of them at once? Sure, if you wanted to, but he's not really necessarily asking for that. I would call this done, either way you approach it. My guess would be that you guys would not put the extra logic in there, and it's still fine. Okay. I like the simpler approach better, but it's kind of good to see both. Let's move on to the next exercise, which is exercise 4.3. This is also another multi-parter, but this one deals with strings instead, so I think this is kind of fun. So it says, write programs that read a line of input as a string and print, so it's kind of similar. So let's start with the first one. So exercise 4.3 part A. New file, save as, exercise 4.3 part A. And this one says, again, write programs that read a line of input as a string and print only uppercase letters in the string. All right. How tough is this? This should be pretty easy, right? How about this? Let's start here. Let's get input from our user. Simple enough, right? How do we find uppercase letters? How do we figure that out? Now there is some code in the book and there's some suggestions. And in fact, I think the book does a lot of really good suggestions. But it does, if you were just doing this on your own, you would be leafing back through the chapter trying to figure out how to do it. So I'm just going to kind of clue you in here because you'd find exactly this. For the characters inside of input string, that's how that reads, we are going to check to see if the character, and you can actually do this, folks, is greater than or equal to capital A, and the character is less than or equal to capital Z, then what are we supposed to do? We're supposed to output the character that's capital, right? So how would we do that? We would just say print character, right? Is there anything else we'd want to throw in there?
In line 12, is there supposed to be space between and and
In line 12? Oh, yes, yes. Thank you, Joe. Good catch. I wasn't even looking at my screen. You should. You should look at your code as you're typing. All right. Will this work? Why or why not? All right, let's try it. This is my thing. Let's just try it and see what happens. It seems almost too simple, and it might just be. So I'm just going to put in my name. Okay, that worked, right? Got my capital T. Let's run it again and say is this okay? Yeah, it works just fine. Absolutely works just fine. Here's some addendums that the author made to this. Is once again, I wouldn't follow his path necessarily, but I want to show you his thinking so that you are in tune with it. All right. He added to this statement. And he added this. Why? Yeah. This is a true test to see if anybody read the book. And here's my answer for you. I'm not giving you an answer. You better go back to the book and read it. There's a reason he's putting that in. It's not really necessary to complete the exercise, but I'm showing you what he considers proper. Let's run it one more time and see what the functional difference is. And so I'm going to put in that same string I typed before. What's the difference? Yeah. Right. He's leaving everything on the same line. So what that little end thing does is it removes the carriage return from the end of the print statement, and then a carriage return is added after it prints. That's what the blank print is about. So it depends on how you want to see it, right? The first one's not necessarily wrong. I wouldn't downgrade you for it. I'm just showing you another way to do it. Yay. All right, you should be excited. All right, so this next one will print every second letter of the string. All right. All right, can I just do a save as right from here? Nod and smile. Yes, you can. This is part B. You don't always have to create a new one. And do I need to get a string?
Yes.
Yeah. All right. But now, clearly, I'm going to need to change this, right? For sure. Do I need to change my loop? Probably. How do I check for every second letter? This is a little bit of a trick. Okay, so here's the thinking. I can't operate on a range of characters the same way that I can operate on a range of numbers, because characters don't fall into a sequence necessarily. They fall into what is called an array structure, which has a length and index values for all the characters. But we have to mathematically get the character positions in order to pick out the characters. So that we have to do with math. So we're going to be switching back to I in range, and then we're going to throw some parameters at it. We're going to start with position 0. Why? Because all strings have a position 0. It's the first position. Then we're going to read in the length of the string. Why?
To see how long the user is each file.
Right. So if it's a 5-character word, it's going to be position 0, 1, 2, 3, and 4. So 0 to 5. We'll stop at 4. See how that works? But we're going to go every other letter, so we can put in 2 right there. and cover it. Now this is not pulling in the letter. All it's doing is setting the index value of which letter we're going to look at. We'll actually look at the letters inside the loop, and we can just go directly to a print statement and say input string, and then in square brackets we just put the index value. So it'll start at 0 and count by 2s. So we'll go 0, 2, 4, 6, 8, and pull in every other letter. I'm going to use the author's little trick. Hey, why not? Let's put it all in one line. Right? And then you know what the last print statement does. This program's done, folks. That's all there is to it. Beautifully simple. Let's save it. Let's run it. All right, so I'm going to type in a string. All right. Nonsense, right? Row 1, first 4 keys. Row 2, first 4 keys. Row 3, first 4 keys, if you're wondering. And I'm going to press enter. And is that every other letter? Q, E, A, D, Z, C? Yes. What if I run it again and put in an odd number of characters? So I'm going to count them out. 1, 2, 3, 4, 5, 6, 7. Oops. Right? 1, 2, 3, 4, 5, 6, 7. Still worked right. All right. Ready for the next one? All right. The string with all the vowels replaced by an underscore. That's a challenging one, seemingly. All right. Let's go back to Spider. Once again, I'm going to do a save as. This is a 4-3 C. So we're going to take any vowel and change it to an underscore. Do I still need the input string thing? Yes. Should I do it in a loop? Sure. Do I want to print a blank line at the end? Sure. It's just the logic that's going to get us, right? So what's our logic here? How about this? We kind of have done this already. If the character in this string that I'm about to type in, A, E, I, O, U, or A, E, I, O, U, could be capped, right? You could put Y in there too if you want, if you want to be weird about it, or proper, depending on how you look at it. All right, so if the character falls inside that range, then what?
What we do is change it to an underscore.
Right, so all we're going to print is an underscore. Right, and then we're going to put in that end thing to keep it on the same line. Otherwise, else, we'll print the character. Right? It wants us to print the string back out, but just replace all the vowels with underscores. This will accomplish exactly that, and now you see the importance of why we're putting in. Oh, and see, here's my screw up, folks. The character, not the I, the character. And oh, and I'm really screwing up here. So it should be the character, not in all this, in the input string. And not one of you said a thing. For each character in the input string, if the character is A, I, O, U, upper or lower, we print an underscore. We stay on the same line. Otherwise, we just print the character. All right, let's give this a shot. Saving, hitting the run button. Here's my string. It's pretty random, right? I didn't even look at what I typed. So there are a lot of vowels in there, though. Did it work? It did. Should we try it with some caps in the mix? Hey, Why not? Right? Seems to be working just fine. All right. Let's move on to the last one. Right. How about the number of digits in the string? That should be pretty easy, I think. Number of digits in the string. So if somebody types in a value, now we're going to check to see how many of those are numbers and count them. All right. Once again, I'm going to do a save as. This is exercise 4.3D. Saving it. Do we keep our input string thing? Yes. Do we keep our loop? Yes. How about what we're checking in the loop? Well, I get the feeling we might have to change some of this. In fact, a good portion of it, right? Are we going to be checking the characters in the input string? Yes, we are. All right. So what are we checking first? How about if the character is greater than or equal to the character of 0? Not 0. You guys ever notice, and some of you might be new to programming, but zeros, when you use the monospace font, always have a slash through them like that? So that you know clearly that it's not a capital O. Really interesting too, most companies that put serial numbers on their computers never use 0 as one of the numbers. They always use the letter instead. Isn't that weird? Yeah, check it out. Check your car, check your computer, and see that I'm right. Sometimes, yeah. And they just do that because it's not that much dissimilar, from look at the O, right? So they put the slash in there so you know for sure it's a number. Right, okay, so if the character is greater than or equal to 0, and the character is less than or equal to 9, yes, as a character, then we're just going to add a count. Count equals count plus 1. Now, I would say what I would recommend is that you preset count up here. Although, hypothetically, well, you do need to preset it, because otherwise, what's the value that you're throwing in there? You don't know. All right. That's it. Oh, wait, we should probably have a message, right? Because they want to know how many. So what about if we do this? The string contains blank digits. All right. Let's go ahead and run it and try it. So I'm typing in a bunch of letters. Here's a couple of numbers. Some more letters. How many numbers do I have there? 1, 2, 3, 4, 5, 6 is my count. Did it work? It did. You guys good? All right, let's move on. All right. The positions of all the vowels in the string. So we can kind of go back now and see, this is where you wish you kept one version open. It's easy enough to retype, I guess. Let's do a save as. This is 4.3 part E. All right. Do we still need to get an input string? Yes. All right. Now, once again, we're going to go back to the technique that we used before, because we can't directly work with the values in the string as numbers, so we have to use numbers to get the positions. So we're going to go with the I in range approach again. And again, we're going to start at 0 because that's where the string starts. And when are we going to end? At the length, at the end of the length of the string. So we're going to do that like this. Start at the first position, end wherever the string ends. Now, our logic to check is going to be different. So I'm going to get rid of all that stuff there. And I'm going to say, get rid of all this too. So up here, we're now going to check that input string in the position that we're currently in, so whatever that is. And if that character is in the range, once again, we're going to go A, E, I, O, U, and you know what, lowercase 2, A, E, oh wow, all right, A, E, I, O, U. If it's one of those, then what are we supposed to do? What's the instruction? The positions of all vowels in the string. So how would I extract the position? How would I put that up on the screen? All I have to output is the I. So if this condition is true, if I is A, E, I, O, U, I can print I. That prints the position, right? Yeah, if you don't believe me, just nod and smile. That is how to do it. And I am going to put like an extra space in there. All right, let's try this, folks. Saving it, running it, enter a string. All right, it's kind of going randomly on the keyboard. Just went right across the top row. Enter. Position 2. Is that position 2? Is E in position 2? Yes, because it starts with 0, 1, 2. That's how it works. And then 3, 4, 5, 6, 7, and 8. Yes, all have vowels. Remember, first position is 0. All right, folks. Let's talk a little bit about what these Fibonacci numbers actually are. And I think a really good way to do that is actually to type in a search on this, the Fibonacci sequence. All right. So this is kind of interesting because you see this is cool. All right. All right. So this is a sequence of Fibonacci. So you 0, 1, 1, 2, 3, 5, 8, 13, and it keeps going. And well, this is nice. We'll keep this page open. So as you keep going higher, there's very specific numbers that it hits. Even more interesting, if you were to plot this out, it creates a pattern of nature that's responsible for like creating that flower. Isn't that bizarre? And the ratios between the numbers fit into like this certain formula as well. And I don't know, so for those of you that are into math, this is a really fascinating number sequence that's pretty advanced. And it takes some advanced math to explain it. But it does basically explain something that happens in nature with numbers. And this is really the beauty of mathematics, folks, is taking something that you see in the natural world that's just astounding and beautiful, and then breaking it down to the numbers that actually make it happen. And you see that nature follows a pattern. So even if we don't, like somewhere encoded in the DNA of the plant or the human or whatever, is these patterns. And you know what? If you could spiral that out, it would just form this huge spiral that keeps going out into infinity. Right? So kind of cool. All right? So this is a helpful little guide. We probably won't take it past these numbers, but we have a page we can look at to see if our work is correct. So here's what I'm going to do for you guys. There is a thing that we do have to get from the user in this program. Let's go ahead and just create a new file in this case. So let's do that part first. This is exercise 4.15? 4.4_15. all right? And it does say that we need to get input from the user. So I'm going to have the user enter an integer, and we're going to convert it right away. So we're going to do that first. Now, they gave us some rules, right? And I'm going to follow what they said in that explanation, and you can pull that explanation up and look at it if you wish. All right. The problem with this sequence is the sequence doesn't really kick in until we get past the second number, and then the pattern becomes more apparent. But the first parts of it are important, so we handle it like this. So we're going to make some new variables here, and the first one's going to be called f new. So if n is 1, the output's going to be 1. If n is 2, the output is also 1. It's when we get past that point that we're going to start to adjust things. All right? So otherwise, if it's not 1 or 2, then we're going to compute the Fibonacci numbers. So they suggested that we have a variable called fold 1 that we preset to 1. And then we'll have fold 2, which we also preset to 1. Okay, this comes right from the book. All right. For I in range 2, comma, n, whatever the user enters. I'm going to tell you with Fibonacci numbers, you have to watch it. You don't want to get it too big because it'll create quite a structure. Then we're going to do the little algorithm that it suggests. That algorithm is this, right? So the new value is going to be the previous two values added together, and then each of the subsequent values will take on the value of the previous. So let me show you how that's done. It's really kind of a shell game of sorts, is the way I kind of look at it. All right. So I'm going to check where it should indent to. And you can see how it doesn't like it. There we go. All right. So the new value is going to be the combination of the two that exist. So 1 and 2. Okay, so if you started at any number above 2. Then we take the second value, place it in the first, and the new value and place it in the second. And that helps us to get that formula going. So if you can, the biggest trick of this problem is interpreting the instructions. And you know what? I know you guys are going to struggle with it, which is why I'm happy to help you with it. But this is a classic little programming problem. And really what the Fibonacci sequence is, folks, is it's a fractal, which is kind of an interesting concept in itself. It's an infinite repeating pattern that grows out to infinity. All right, let's just take it for what it's worth and assume that our math is correct. So they want me to enter an integer. I'm going to put in 5. Press enter. That seems way too easy. The Fibonacci number 5 is 5. Let me check that web page. Is that correct? Is 5 equal to 5? You know what? It is. I happen to know that one by heart. Let's try a bigger value. Let's run it again. And let's put in, I don't know, 9. Is it 34? Oops. 9 is 34. Let's try 14. Looks like it's working just fine. It's a really bizarre sequence of numbers. And there's a lot of mythos and mythology and thinking that goes behind this. It's a really basic number sequence, but sometimes those really basic number sequences are what describe really seemingly complex patterns in nature. Just a matter of identifying it. I'll leave that up on screen for a second. In fact, I'll just pause the video here while I'm recording. All right, let's move on to 418. And this is kind of a classic programming problem too. It says, write a program that prints a multiplication table like this. So we want to start at the result of 1 times 1 and end up at the result of 10 times 10. So this is kind of an interesting thing because we have to obviously run a loop that runs 10 times within itself 10 times. Catch the trick? Because to go across, we're looping 10 times, and then to go down, we're looping 10 times 10 times. So this is actually what we call a nested loop, and this is the only homework example of this, but it is a pretty important concept. So let's build this out. This is one of those things that takes a little bit of patience to do the first time that you encounter something like this, but I assure you it's not really that difficult, just a matter of seeing the pattern. Once you have the pattern, it's a piece of cake. So let's call this exercise 418. I'm going to blow away all the code that's here. I did a save as. Probably should have just made a new one. All right. Now, you can do this a couple of different ways. The author does this, mind you, using a constant. I'm not going to do that. I think it's kind of silly. All right? However, the constant could be useful if you want to alter the structure of this, but I know when I was a kid and I learned my multiplication tables, I mean, we just had them written on pieces of paper, and you just kind of had to memorize it, right? You know, whatever your trick was for learning it. But it was usually in columns of 10 numbers anyhow, right? So that's why the author is working that. So the author presets a constant. I'm going to skip that. I'm going to go right to the loop, folks. So what I'm going to do is I'm going to create 2 loops, an outer loop and an inner loop, and I'm going to create the outer loop first. So I'm going to use y as my counting number, and I'm going to declare a range, and here's my range. 1 is where I'm going to start, right? Because I'm not going to start at 0, I'm going to start at 1, because 1 times 1, right? And then, what am I counting up to? 10 for each row, right? But to get it to go to the 10th number, I actually have to add 1 to it, so I actually have to go 11. What the author puts in here is the name of the constant plus 1. And that way you can make it as big as you want by just changing the constant. I'm going to hard code the number. Sorry, author. All right. Now, here's the little bit of the mind bender for those of you that have never done this before. And what you may end up doing if you're trying to create this from scratch is this. You might end up writing the inner loop first to have it make sense to put it inside the outer loop. So here, what I'm going to do, I'm going to run the same thing again, 1 to 11. And then for each time, that we run through that loop, we are going to print out some values. Now, here's where some of our formatting stuff comes in. All right, so you guys may not remember all of this by heart, and that's okay. You can go back to that chart and look it up. So this comes from a little bit of practice, mind you. So here's where the math happens. Isn't this interesting? So the outer loop is going to operate, and it's going to run through 10 times. While it runs through, every time the y will change. You guys catching this? And then every time the y changes, you're also running through the loop with x 1 through 10. So for every y, so if I start with 1, it's going to multiply y is 1, x is 1. Y is 1, x is 2. And it just does it like that. And then when it finishes all the x's, it moves on to the second y and keeps going. And then all we're really doing here, I mean, this is the math part right here, right? This just does the formatting. Because we're going up to 100. Why does it choose 4 decimal places? to leave one space extra for the 100, right? And then we kind of want to put these on the same line, so we're going to use that end trick again, like so. Then the other thing you'll want to do is every time it finishes a row of X's, you want to just put it in a blank print line so it goes to the next line. That's your whole program, folks. Isn't that crazy simple? What's not simple is figuring out the logic, right? Once you see the logic, though, it's going to make a lot of sense to you, at least I think. All right? And there's our output.
Wow.
Pretty rocking.
For 4 lines of code.
For 4 lines of code, that's pretty rocking. It really is good. Some of the magic is in this formatting statement. So like you could like remove this, and I know that if you're in the Java class, you probably had an assignment just like this, at least when I teach Java. I assign the multiplication table one, and then, you know, students are always struggling to get the formatting because we don't always worry about formatting so much in Java necessarily. But here in Python, it's so simple, and it's really not that much different in Java, frankly. But that's the completed exercise. All right, this video ends here. That's all the exercises in that chapter, so that's everything.